Well, thank you for joining us on this presentation of our SuperNAC remote access features for IoT security. I'm Scott, and I'm really excited to talk to you today because I absolutely love this stuff and because what our developers have done is nothing short of amazing. First off, a couple housekeeping items. This presentation will be about 30 minutes long, generally non-technical, but we do use industry terms. There are a couple areas where we do get down into some packet captures, but don't let that scare you away. We're really focused on real application and use. The slides are meant to be no frills, reference material without a lot of fluff. So with that, let's go. I'm going to cover some three basic points here. Over this presentation, I'll tell you who we are and what we do, really dive down into what the real problem is with connectivity and security in the IoT space, and then, of course, our solution to those problems using our SuperNAC Trust and Control feature set. Quick bit about us. We are the designers. We're the manufacturer. We design, build it, ship it. It's our stuff, our source code. We also have many patents on our innovations, as well as a few more coming out this year and a few awards under our belt. We've been global-centric from day one, which is great because we're able to take industry knowledge and real market conditions from all over and actually incorporate that into our solutions. So connectivity is a challenge and security is really no longer an option, but it's still difficult and non-existent out in the market. And many reasons is because, well, the market hasn't kept up, vendors pushing their favorite solution, or simply this is just the way we've done it. But here's what's really happening. Devices and appliances expect to be online all the time. The network is now everywhere, except the office. And the idea of perimeter security is absolutely gone. And the real driver behind this is what's called fixed application devices. IP phones, IP cameras, badge readers, alarm panels, things like this. There is no, hey, let me just put an app on there and get security. In the old days, like yesterday, physical security was just that. You had physical control. But now with networking and the internet, you don't always know who you're dealing with, and you can't just go over to the door to see if it's locked. If you need a one-sentence description of what we do, here it is. We have created and assembled field-proven technologies that provide the most reliable, cost-effective, and secure remote access for any IP internet connection anywhere. Also, I want to take a moment right up front to actually tell you what we do. So, of course, we already said we make the products, we build them, and securely and reliably connect networks and devices just using commodity internet. We're really strong at unblockable secure tunnels that take VPN to the 4th generation. We also do failover and redundancy really, really well. And now, with our SuperNAC features, we can provide closed-loop security end-to-end. So the short answer of why us? Well, we work where others can't. Our social proof is very strong. We do what we say, our support is superior, and we work. Now, don't believe me. You can actually see some of the company that we keep and so what some real people who really use our products say. We've recently won a couple major projects utilizing the features that we're going to be talking about here in this presentation. Needless to say, we work in real mission critical and security critical environments. Here's a snapshot of our product line. We support connections from 1 to thousands. We support architectures that are point-to-point, point-to-multipoint, full mesh. And the good news is they all run the same software and have different peripherals as needed for specialized applications. So whether you need a low-cost remote for a fingerprint scanner or a virtual headend under VMware or Amazon AWS, we've got that covered. These next slides kind of highlight some immediate questions you may have right now. So first off, yes, we work with dynamic IP on both ends of the link. For maximum security and compatibility, there are no drivers, there are no software clients. We work with Apple, Windows, Android, you name it. As long as it's got an Ethernet port or Wi-Fi, we can connect with it. There are no trick licenses or recurring fees, and this is the most important part. Your data always goes between your devices. Very, very important, unlike other solutions in the market, we can set up and operate our SD tunneling and SD failover as your own network without any reliance on someone else's servers or services. This immediately knocks out guys like Cisco, Aruba, Microtech, Peplink, Juniper, you name it. Plus, in addition to the connectivity, we bring the identity-based network access control that enables you to lock down your network and remote access using our feature set. So let's talk about now what some of the real security challenges are in IoT. Now, there's a lot of noise in the market about what IoT is, and here's a little definition slide that I put together to kind of make it real. And the real focus is on what I talked about before, fixed application devices. It is what it is. You get it from the manufacturer, how they implemented their security stack, and how they implemented their protocols. You're not going to change it. And it's really tough to get these to work properly over the wide area or internet, much less trying to get them to be secure. Here's a set of screenshots I did getting ready for this presentation. It's actually quite depressing. We have a lot of devices that are out there, and basically admission that, yep, they're not secure, and they're not designed to be secure, and they're never going to be secure. If you look at some of these researchers up here, they're like, well, it's just what it is. You're going to have to get over it, and okay, you're going to have to live with it. I'm not sure if I'm running a production network where I'm trying to protect people's personal information or credit cards or my own finances that I'm okay with a researcher saying, just get over it. Of course, they have no skin in the game, so they can say whatever they want. But what's interesting is over here from the channel partners, they actually kind of highlight really what the big problems are. And they're the same problems we've always had. People scanning and packet capture, brute force attacks, denial of service, tampering. So it's all the same stuff we've been concerned about before, and now is just pervasive because of the number of devices that are out there. So the answer is, let's put in a VPN router. Well, that actually causes more problems than it fixes. So while you may be able to readily implement strong encryption for your data in motion, if you know how do you deal with the remote network objects like an IP camera, or someone just plugging in their laptop, or blocking your server so you can't see what's happening remotely, or swapping out the camera stream for another one that happened a week ago? So this idea of trust is gone. The world of trust and verify is here. And you have to have full end-to-end security or you're dead. And the big three, spoofing, sniffing, and tampering. So of course, IPsec VPN with a firewall is a big fail. And we boil this down really to what are the three big problems. Is my data secure? How do I get people that I don't know off my network? And is my device really the device I think I'm talking to? That's it. Now, I'm going to use IP cameras as the example here because, well, they're everywhere. And if you're in IT or physical security, you're using IP cameras. But it's also what I have available for me, easy to use, so I'm going to use them in my presentation. But this really applies to SIP phones, RF panels, alarm readers, you name it. It all works pretty much the same way. Now, most IP cameras are not secured. You can use basic authentication, or you can use digest authentication. These are different methods, but they're all generally unsecure. And in fact, there are websites upon websites that will give you the passwords, the factory default passwords for these devices. One of the ways that they use security to secure a video stream right now is using this thing called an MD5 hash, and we won't get deep into it, but just remember this little box here, and remember things like the username, realm, password, URI, nonce. Just remember these items here. We're going to be talking about them in a few minutes. The problem is MD5 is absolutely insecure. It was cracked back in '96 and globally deemed insecure in 2004. And in fact, there are websites out there that will sell you what's called a rainbow table, which will show you what all the password character combinations are and to develop hashes for that. And it gets worse. Go ahead and look at this YouTube video of these guys from MIT that show you step by step how to tap into a network stream of an IP camera and record it and then play it back as if nothing were wrong. And one of the things that they can do is actually play back that video stream and still keep the timestamp that's coming from the original camera. So they can hide the bad stuff that's going on while making you think that it's still their live stream. And these are readily available open source tools today, right off the internet. But let's walk through a real example of an IP camera. Now, this is a packet capture that we did off the wire of a client talking to an IP camera. We won't get down into the weeds, but we'll do a little 1, 2, 3 on it. So what happens here is a client requests a video of the IP camera. The IP camera goes, yeah, sure, okay, I'll play that video for you, and voila, you see the video in the camera. No authentication, the stream is unencrypted, but you're not doing any authentication, so it's wide open. You can't have any surprises there, right? Well, let's take a look at what happens when you do have a video camera that uses pretty standard authentication. Again, we request the video. Now, the client requests the video without using the username and password. And if there is no username and password, it'll just play it. But the IP camera says, nope, I need some authentication. So it says unauthorized. And then it spills out a whole bunch of information. We'll show you that in the next slide here. And if you're watching on the wire, you can capture all of this. And oh, by the way, the stream is still encrypted. So you get the video and you get to still see the unencrypted stream. So you may not even need the username and password. You can just watch what's going on. But let's look at what happens. So here's the username password for that IP camera in VLC client. This is the actual string I used for that last video. And you see the password is capital P, @SSW, and then the number 0RD. Okay, a little bit, trying to be a little bit tricky there. Client makes that first request, gets unauthorized because it says there's credentials, and then it spills out all of this junk from the camera without even asking. Username, realm, URI, nonce, all in the clear. So if I'm watching on the line, I can see all of that. Now you'll notice there is no password in the clear. So it means we're all secure, right? We can all go to sleep. Well, not exactly. So you remember that box with all that math in it? Well, what you do is you take all of those elements, you put them in, and then we could start doing a brute force attack against the password until we get the video stream we want. And oh, by the way, you remember those rainbow tables? There's one online. And I actually took the hash of that word password, and it immediately came back and found it in its hash table. Again, may not need to even crack the username and password. It is video still in the clear, so may not even be a problem there. So now we're going to talk about how do we solve these problems. And we want to be real clear about what problem are we solving, right? First one is, how do I keep somebody from getting onto my network? And two, am I really in control of the devices that are on my network, right? And SuperNAC really enables you to do these kind of things, answer these questions. So here are 6 features that we are rolling out under the SuperNAC feature suite that provide you that identity-based endpoint control and network control and access control. And you compile these on different ways depending on what you want in your security policy and your business policy, but they're all there to lock down your network, lock down your devices, so you know who's on your network and you know that device you're talking to is the device you think you're talking to. So let's look at some examples here. So this is the port dice feature set under SuperNAC. And this is how we protect the head-end network from unauthorized access. We created a system where the head-end server is completely blocked from any inbound tunnel requests. And an enrolled remote appliance over here actually doesn't know how to connect to the server. It has to be told out of band using some two-factor authentication techniques to actually understand where am I supposed to connect to, how am I supposed to connect to it, and it will not do that until it receives that command back from the server. So if somebody just took this device, they actually don't know where it's going to go to. The head-end server then authenticates the remote appliance and then tells that appliance how to connect to it. And once the server knows who that is and authorizes that remote appliance, it will actually create a firewall rule that will cause a pinpoint hole for that appliance's IP address only to connect in. So you know that that appliance is where it's supposed to be, and it's going to connect to here based on the parameters of where it is. This also has great denial of service protection because you don't know where it's going to be. You can port scan this all day long. You're never going to get a connection off of it. Now that the tunnel and connection is secure, let's talk about how we protect the head-end network. And we have an exclusive feature called IP share, which will block all upstream network activity until triggered by the head-end network. So here we have a list of features that IP share will do. And basically what it does is it gives you a bridged connection all the way to the IpTL appliance, which is here, and then isolates the remote network from your head-end network. So this gives you basically a tunnel net right here with a firewall, and allows you to do some interesting things. One, you can have overlapping IP addresses. You do not have to reconfigure the upstream router at all to use the tunnel. And you get direct access from the head-end network to individual devices and services that are programmed. And what's really interesting about this is that until the head-end operator actually makes a connection to a device like this IP camera, there is no traffic coming up, even if the IP camera is in the table for approved devices. So let's see how this works. We have an auditor over here, number 3. He wants to look at the video camera, number 4. And so he opens up his client or application and it goes over, and the IP share sees an incoming brand new connection and says, I want to talk to the IP camera at 4. And so he goes, oh, I see that. He's an authorized user. I'm going to open up my firewall and let the traffic go to the camera. And then I'll also simultaneously connect the camera's return traffic to that connection and allow that to traverse the firewall. So this gives you the ability to not just put a rule in that it authorizes this camera, but it actually authorizes it at the application level, triggered by the head-end user. And once the head-end user closes that session down, the firewall zips everything up and is completely isolated from the head-end network back up from the remote network. Now, one of the ways we provide conditional access control is using and verifying the cert of a local appliance. Any appliance that offers an HTTPS web server can be queried with our Trust ACL cert feature. And once we get the cert, we can verify it in several ways, including normal public key or use a loaded root cert into our device to verify it. In the example here, I've actually pulled the real cert off of a Honeywell NVR that I'm using in my demonstration. And we can use that then to trigger dynamically ACL firewall rules to permit or block traffic over the tunnel. So we can query this device, and if we get its cert back after we verify it, then we can enable traffic over the tunnel. But if we all of a sudden query this device and don't get the cert or get the wrong cert, we can actually create a block situation and an alert. This gives you the greatest granular control without an agent deployed to say, this is the device I think I'm talking to. Now, what happens if a device doesn't have an HTTPS server on it? Well, we have another method with that. We can actually fingerprint a network device, and we take several aspects of what that looks like on the wire, and every network device has its own characteristics, and we can build a model of what that device looks like. So just as I have gray hair and light skin, and I'm 5'10", we can build a model of what that device looks like, and if all of those parameters match up, then we can let them onto the tunnel. If all of a sudden that disappears or there's a swap out, then we can block it. And so this, as you can see, goes way beyond MAC address firewall rules and really combats spoofing, because it's more than just being able to change the IP address or change the MAC address. You actually have to make it look like that device. One of the more interesting features is the Trust ACL app, where we're actually only allowing certain application services to come through the tunnel. And this is really important for certain IP cameras and devices that might be polluted or have backdoors in them. We can actually block the access of that device, backdoor, or unauthorized application up the tunnel. So in this case here, you see we've got a backdoor from a bad guy going through an IP camera. But actually, we're only allowing the video stream to come through the tunnel. Anything else, we're going to immediately block. And this gives you complete layer 7 control over what comes over the network. One of the most interesting features actually is this Trust ACL interface. This is where we can tie a unit to a device, provide full identity and encryption services on a port-based level. So now we can even go further and say this camera is tied to this port with these type of identity features. This NVR is connected to this port with these type of identity features, and pull all that together so that if somebody tries to swap one of these out, we get an immediate alert, and this gives you real continuous isolation and monitoring of your remote network assets. Now, we often get asked the question, what happens if somebody takes a device home, walks away with it, we lose it, and it happens? Well, it's real easy. On the server side page, you have a button called Revoke. And if you think you've lost a box or not sure where it is, you hit Revoke and it will not allow it to connect up to your network. It's that easy. And if you want to put it back into play, you can always go back to the tunnel page and reinstitute it. It's a non-destructive way to shut down, and it's meant to be temporary, shut down a connections until you know what's happened with that device. Now, if it's truly stolen or truly lost, you can brick it, and that actually wipes out all of the memory. And if you want to use it again, you got to send it back to the factory because it's done for. So how do you deploy this? Well, there's two models, local and centralized, and actually you can combine them if you want. But really, local is more interesting because it allows you to adapt the device and appliance to the physical area that you're trying to protect. Centralized can work. You can bring all your devices in and manage them from a central location, but it gets a little bit more tricky when you're dealing with more than a few remote locations. But you can always combine them too. So you can provide local for the local assets and then centralized to manage, let's say, the appliances themselves out into the network. And here are a couple of architecture pictures of how you can actually deploy the appliances into a network. So we've got inline, where we are the access router for the whole network. You've got a stub where we're just put onto the LAN. And then, of course, the direct connect or enclave, where we can actually separate out the network assets from a local enterprise LAN. So what does this protect against? Well, if you've got an IP camera, you can actually encrypt the video streams and prevent others on the enterprise LAN from actually seeing the traffic that's going across. Now, there are NAC solutions out there today. Pick your favorite vendor. But they're all focused really on enterprise mobility management, BYOD. It's how do I manage users that are traveling between offices with their laptops and their iPhones. They really don't address the IoT or the fixed application device, right? They want you to put a client, create a special area on your phone that is just for the BYOD, and that's great, and that serves a need. But what happens if I've got a manufacturing device, a PLC, like this guy, and how do I secure that? This is actually from the Aruba forum. I was just searching on the web, and it came right up, and wow, it looked really good. So this gentleman's looking to secure his manufacturing PLC devices, and Mr. MVP over here goes, well, we generally use MAC authentication. Well, that's a MAC address that is so easily spoofed with tools off the internet. Doesn't really provide authentication. The other way to do it is put an 802.1x client on your PC, but you can't put a client on a printer or an IP camera or access control reader. And maybe it's got one built into it, and that's all good and well, but the way 802.1x works is, well, it only authenticates at the establishment of the link, so you've got a hijacking problem with that. And of course, no data is encrypted anyways. So this is just admission to the network, not really securing your data and keeping it private. So what do? Well, we secure your data in motion. That's using our TLS with the AES-256. We've got the appliance and link protection. This gives you remote server appliance attribution and full NAC, as well as the network access protection with IP share and the SuperNAC feature set. How is this going to show up? Well, it's a licensed feature, and it'll show up in the top ribbon bar of a licensed appliance, and from there you'll be able to enroll devices, manage alerts, and manage all of the features I just talked about. It will be a perpetual feature license across all of IpTL's product line. You can add this to existing products. We actually license it one per appliance. So there are no per host or per device licenses. They're unlimited. So if you've got 10 sites with 50 IP cameras across those 10 sites, well, you only need 10 licenses for each of the devices. We are in customer betas now, so if you're interested in partaking, please let me know. And we're looking for full launch at the end of June. We also have a technical hands-on training session coming up. So if you're interested in that, watch out for registration. We'll be making some announcements on that. We also have some online technical training at YouTube. So just go to our YouTube channel and you can take yourself through some hands-on technical training free of charge. And we're positioned really, really well. We have a full 200-point matrix going point to point of how we stack up against the usual suspects. There's a full package there you can download of our security documents as well as our competitive feature matrix. And so we ask you to help yourself to that. And of course, if you have any questions, please reach out to me. I'll be happy to talk to you about your project or how we can fit in and support your initiatives. Thank you.